So here we have a squared minus b squared plus 12b minus 36. How do we factorize this? So there is an incorrect way to factorize this, which is like partial factorization, meaning that you didn't fully factorize the given expression. Remember, when you're given a whole expression, you want to factorize the whole thing as much as you can. You don't want to factorize in parts and leave other parts unfactorized, or maybe factorize separate terms. What do I mean by that? So for instance, let us look at the first incorrect way to, let's look at the first and only incorrect way to factorize this. Here you will look at this, it's a squared minus b squared. Difference of two squares, right? So you would go ahead and say a plus b, a minus b. And then you will look at this and then you would be like, okay, 12 is a factor here. You can take out 12, you're going to be left with b minus 3. And then you would think, okay, we factorized, we're done. This is technically incorrect as far as having to factorize the whole thing fully because of this sign over here. When you factorize the whole expression fully, you want to make sure that the terms are not separated. It's just one term, meaning that you just want to have something over form in brackets where it's just brackets multiplying each other, not brackets or terms adding to each other. So here we can see that, okay, we have two terms. We just want one term. One term would be something like this. It could be 2 brackets, it could be 3 brackets, it could be many brackets, as long as all of them are multiplying to each other. That's what we mean when we say we factorize to the fullest. But yeah, we can see that the positive separated things here, separated the brackets. I mean, we can write this 12 as a bracket, yes. So it separated the brackets. But we want all of these brackets to multiply to each other. That's how we want to factorize. That's what we mean by factorizing to the fullest, factorizing fully. So we saw that that didn't work. Okay, bummer. What is the second option? We have what we call a trinomial factorization, right? Meaning that if there are 3 terms, you can factorize it. So when you look at this, it looks like it could be factorized. There's potential there. And then this a squared, let us leave out this a squared, but it will come in handy as far as having to factorize everything is concerned. Let's write a squared, and then on this part over here, let us factor out the negative. So it's going to be negative. You're going to be left with b squared minus 12b plus 36. So this is a trinomial. There's a b squared, there's a b, and then there's no b there. So that is the easiest way to notice a trinomial in which you can possibly factorize. So let us see if we can factorize this. So it's going to be b squared plus 36 minus 12b. So it's going to be bb 36. What are the factors of 36? It's going to be 6, 6, because 6 times 6 is 36. Then we could put negative here because negative multiplied by negative is positive. Cross multiply. You're going to get minus 6b. When you add them, is 12b. So, a squared minus b minus 6. If we rewrite this, it's a squared minus b minus 6 squared. So now, I'm pretty sure you can look, okay, we're still not done because, 2 terms are being separated by a negative here. Or it could have been a positive. We just want, if it's fully factorized, we want it to just be one term, brackets multiplying each other. But what can we notice here? Difference of 2 squares, right? Because the exponents here are 2, and then there's a negative over there. And so we know that with difference of 2 squares, take the first term, use a negative first, and then the second term, now you use the positive, while keeping the terms as is, right? When we further simplify this, it's going to be a minus b plus 6. A plus b minus 6. So now here, we can see that we have 2 brackets. Even though in each of these brackets, we have, you can say 3 terms each. But the overallness of everything, the whole thing, it's in 2 brackets. So that is the aim when we factorize. We want to look at the overallness of everything. We want to make sure that they are in brackets so that it can just be one term. Remember, if 2 brackets are multiplying to each other, this whole thing is just the one term. So that is the aim of factorization. You want to look at the whole thing when you're factorizing an expression, look at the whole thing. Break it down into pieces, but make sure that if you're going to break it down to pieces, it's going to eventually lead to just brackets multiplying to each other, right? And I hope I at least made sense to some extent. And yes, that is how you factorize this given expression. Hope you found this helpful, and thank you.